This is part 2 of topic 1.1, an introduction to instantaneous rate of change. This part is going to include 2 examples. So the first example is about a hypercoaster, and it's a special circuit roller coaster with a height measuring greater than 200 feet. So if a new hypercoaster is under design to have its largest drop on the circuit, modeled by the equation we have right there, the d of t, where distance is measured in feet and t is time in seconds, we want to find the average speed of the hypercoaster from 2 to 8 seconds. Now this equation is a little more complicated than the last one, so I'm going to use a graphing calculator. And if you notice here in the corner, it does show that this would be a calculator type problem. So what I'm going to do is I'm going to say the average rate of change is going to equal d of 8 minus d of 2 all over 8 minus 2. And I'm going to use the graphing calculator in the table to give me these values. So I went ahead and I put the equation into the calculator. If you notice, I used x and not t. And now I'm going to do something with my table to make it a little easier to use for problems like this that we're going to do in calculus. I'm going to change my table settings, and I'm going to change the independent variable from auto to ask. And when I do that and I look at my table, what I'm going to see is that it's blank, and I can enter my x values. And that's going to come in important. That's going to come into use later in the problem when we're looking for the instantaneous rate of speed. And we have these different changes here that are hard to put in a table and see them without continuously changing the scale of the table. So by putting your table on ask, you can put in the specific x values that you want. Now, in the Inspire, don't worry about the screen right now, but if I show the, I have the function in here, and I'm not really worried about looking at the picture because I just want values, I want the table. So in case you don't remember, if you go under menu and you choose 7 table, and you can do the split screen table, and then from there we have the table here, but I have all the values filled in. I can do the same thing as long as the black box is around the screen here. I can go into menu, table, and I can choose to edit my table settings, and again I can change my independent variable to ask, and it'll give me a blank table. Okay, so we're ready to go. So then what you do here is you can just put in the values we want. So we want the value at 8 seconds and the value at 2 seconds. And those are the values. In my 84, it'll be the same thing. I can just choose 8 for x and choose 2 for x, and those are my values. And there is something wrong with this one. There must be something wrong with my equation because those values are too big. Oh, I see. I forgot a decimal point here. So let me insert that. There we go. So now let me look at my table. Oh, much better. There we go. Okay, so I'm going to write that down on my paper then. So I have these values to enter. I have the speed, or the distance at 8 seconds is 671.36 minus at 2 seconds, which was 290.54, and we're dividing that by the change of 6 seconds. So this is going to be approximately equal to 63.47 feet per second on 2 to 8 seconds. And remember, I talked about this in the other video, because our average rate of change is going to be different depending on the time interval. You want to make sure that you're specifying the interval of time. Okay, so then part B says, let's do this again, but from 4 to 6 seconds. And you're going to see that we get different values. So you can go back to your calculator and then go down and add 4 seconds and 6 seconds, and the same on the Inspire. You can add 4 seconds and 6 seconds, and then you have those values. So we can go back and fill that in our paper. So our average rate of change is going to equal D of 6 minus D of 4 over 6 minus 4. So this is going to be 470.18 minus 373.16 over a change of 2 seconds. So this is approximately equal to 48.51 feet per second on the interval from 4 to 6 seconds. And as you can see, these two values are very different from each other. So that's why it's important that you include the time interval. Okay, so now what about at exactly 5 seconds? So I have given you the time intervals that you need. So I am going to go through and put those in my calculator, same thing. So I need 5 seconds, and I need 5.1, and then I need 5.01, and I need 5.001. And those are all the values I need then to do the last problem. So I put them all in. You only have to put the 5 in once because you're going to reuse that one as we get closer and closer to 5. So my formulas are going to look like this. So for the first one, I'm just going to do the first one in the table, and then I'll just write the values for the other one. So I'm going to do 419 minus 414.26 over 0.1 second change. So this is 47.399. Okay, and then the next one, when I do the same kind of idea, I get 46.714. And then finally, the last one will give me 46.647. So what we're looking at here is this is pretty close. So the meaning of our instantaneous rate of change is going to be our instantaneous speed, forgot a letter there. Spelled that very badly. Instantaneous speed is 46.647 at t equal to 5 seconds. Okay, so there's that problem. Now the last one. Now we're dealing with something besides speed. We're dealing with traffic patterns of departing flights at the Orlando International Airport, and they're modeled by the function v. V of t is 92 minus 15 sine t over 3, where v of t is measured in vehicles and t is measured in minutes, and we're looking between 0 and 30 minutes. Now one thing I want to point out is this is the first time that we're using a trig function, and all trig functions in calculus are radians. And we'll get into that later when we start using them a little more. It's the way they're defined. They're defined in terms of linear measurements. So linear measurements lead us to radians from our arc length formulas and how we defined a radian. So you want to make sure that your calculator is in radians for this course. Okay, so the first thing we want to do is find V of 18. So in order to do that, we're just going to substitute 18 in, and we get V of 18 is going to equal 92 minus 15 sine of 18 over 3. And when you do that, you get approximately, you just substitute that in your calculator. You just want to make sure it's in radians, and I'll show you that in a second. 96.191. So this relates to about 96 vehicles. Okay, because we're talking about vehicles, so we have to round it for it. So we're supposed to make a sketch of our graph. So here's what I'm talking about. When you go under y equals here, you want to look at the very top of your calculator if you're on an 84, and it should say radians. If you're on an Inspire and you go to your home screen, you want to look at your settings. So you choose 5 and you want to use document settings. And if you notice, I have degree in here for my angle, and I need to change that to radian. And then I want to make sure I make that the default, and I should be good to go now. Okay, so I'm going to add a graph page to add the function, and I'm going to work from there. Or actually right now I could just add a calculator page to do part A, but we already did that. So I'm going to enter the function, which is 92 minus 15 times the sine, and my trig button is here, it's hard to see, times the sine of x divided by 3. Okay, and then I'm going to hit enter, and this is not going to show up because if you think about it, on our Part A, we had at 18, which is almost in the middle of the time. We were almost at 100 vehicles. So we want to split this up a little bit better. So I'm going to label the bottom in terms of 10-second intervals, or 10-minute intervals. I apologize, it's in minutes. And this is just a sketch, so I'm going to make a very rough sketch here. So what I'm going to do in the calculator, though, is I'm going to change my window settings. So if I go under Window Zoom and do my window settings, I'm going to go from 0 to 30, because that's our time interval. And like on my graph, I'm going to count by tens. Whoops, too many ones. Tens. And then my Y's, again, I can not have negative vehicles. And I'm going to go a little over 100. So that I can make sure I cover everything I need. Whoops, so I want this to be 10 is probably a good estimate too. And there's the graph, very nice. Now the nice thing about the Inspire is when you hit trace and you hit graph trace, it'll hit all the high points and low points for you and tell you you're at a maximum or minimum. And I don't know why it's doing that. It just went bizarro on me. Let's go back here. Let me just put in 0 for a value. Let me go back there. Okay. All right. So that's one value I do need, the y-intercept. So I can put that on my graph, 0.92. And then, oh, I just hit a minimum. So I can put almost 577. So let's just do those two real quick. So on my graph here, I know that I have, let's put 77 like right there. And that was at like almost 5, so that would be like right there. And then our y-intercept was at 92. So we have a point there. And going back to our graph, let me move along here. And find another maximum, which is at 107, right around 14. So I can put that on. So that's almost halfway. Here's 107. And here is right around there. And then there is one more minimum in our time frame, because we're going to 30. And we'll see that there's a minimum at 23. And it's a symmetrical graph because it's a sine graph. So the minimum is again at 77, so that's almost at 24. So we're like right here. So our picture looks something like a nice sine graph like that. Okay, so that's a good sketch. Now on the 84, what we can do is put that function in, 92 minus 15 sine of x divided by 3. And again, I'm just going to go in and set up the window real quick. We're going from 0 to 30, and we're going to count by tens. And then the y's, we're going from 0 to 110, and we're going to count by tens. And now we're going to hit graph. And the difference here is that it's a little harder to find those points. I'm just going to show you how to do one, and then we'll go from there. So to find if we hit trace, it's easy to find the y-intercept. You can just type in whatever x you want, so we can hit 0. It'll take us right to the 92. But to find a minimum or maximum, you want to hit second trace and then choose 0. And you want to be to the left and right of the 0. So kind of close, so you hit enter. And then you want to make sure you go past the bottom here. I didn't want 0, but I think I'm going to get an error message because I wanted the minimum. Yep, that's my fault. Sorry about that. So we're going to hit second trace, and we're going to choose minimum. So let's try that again. Okay, so I'm past to the left of the bottom, to the right of the bottom, and then I'm going to choose enter, and I get a value of 77. And then if you want to do the maximum, you have to hit second trace and choose 4 maximum. I'm not going to go through and do all those right now. But anyway, we have our graph. Okay, so now what is the average rate of change of the vehicles at the departing flights over the time intervals between 15 minutes and 20 minutes, and indicate the units of measure? One thing I'm going to comment on here is that on the AP test, you only need to include units if the test questions ask for it. So we're going to do V of 20 minus V of 15 over 20 minus 15. And we can get those values from the table as we did before. So 86.3877 minus 106.3838, and that's all divided by 5. Now you might notice I used more than 3 decimal points. When you're doing any problem, keep as many as you can. It's just your answer you want to round. And this comes out to be 3.999. So this is going to be about 4 vehicles, because remember we're talking about real things, so we have to round it. 4 vehicles per minute between 15 and 20 minutes. And again, you want to include that time interval. Okay, and then finally, as in the other problems, we want to talk about the instantaneous rate of change at 18. So we're going to find the average rates and then finish it out. So I'm just going to put the values in there for you so you have them. You can go through and do the details. Let's try your calculator out, see if you can set it up like we did on the last problem. And then finally the last one is negative 4.801. So the instantaneous rate of change at t equals 18 so that 18 minutes is going to be, and I want to put this on here before I write the value, and it is decreasing because the value is negative. So it's decreasing at a rate of, I'm just going to make it 4.8 vehicles per minute. And just to wrap up our concept here, why can't the instantaneous rate of change of traffic in the departure lane with respect to time be calculated using the method in Part D? Because we would be dividing by 0. Just to reiterate that, that's why we can't use our average rate of change. And that is our introduction to instantaneous rate of change.